Okay, so here's practice exam 2, part 1. Wants us to graph this function. So how do we graph it? Well, first off, x to the fourth, that's like x squared. It's a u-shape. These are all u-shapes, though, so that doesn't eliminate anything. I would make a table. So let's make a table. And what do we plug in to find the center of the u-shape? You plug in whatever will make x's little world 0. That would be 2. So plug in 2. Y will equal 1 minus 2 minus 2 to the fourth. 1 minus 0, 1. So over 2, up 1. That's the center of the u-shape. And then I would add 1 to find another point. Plug in 3. Y will equal 1 minus 3 minus 2 to the fourth, which is 1 minus 1 to the fourth, which is 0. So over 3 up 0. So the u-shape must be going like that, because there's 2, 1, and there's 3, 0. Which one has 2, 1, and 3, 0? That one. Answer C. Let's try number 2 here. Okay, so this one, again, I would make a table. So x, y. What do we plug in? How do we find the center? We plug in whatever would make x's world 0. That'd be 2. So y will equal 5 plus 6 over 2 minus 2 squared. That's 5 plus 6 over 0. Now that's undefined. 6 over 0 is undefined. But we pretend, remember what we do here? We pretend that that part's 0. So it's 5 plus 0, sort of, which would be 5. Now that's not a real point on the graph. It's really undefined there, but that does help us find the center of the crosshairs. The center of the two asymptote lines will be over 5, up 0, right there, at 5, 0. No, what am I doing, 5, 0? At 2, 5. Let's try that again. 3, 4, 5, over 2, up 5 right here. That's going to be the center of the asymptote lines. And over 2, and over 2 up 5. That's the center. Okay, now, then we add 1 to get one other point. Plug in 3. Y will be 5 plus 6 over 3 minus 2 squared, which is 5 plus 6 over 1, which is 11. So over 3 up 11, so way up here. It's got to be a branch way up here, and then another one here, because the x squared are always side by side. So which one has the crosshairs over 2 up 5? Looks like that one, huh? It's the only one with the crosshairs over 2 up 5. Answer C. Okay, number 3 here. Which function is right? Well, it's all about the horizontal and vertical asymptote lines. Notice right here at -5 and right there at +5 are verticals. That means there's x minus 5 and x plus 5 in the denominator, which multiplied out is x squared minus 25. So no way, no, whoops, that was okay. So no way on A, no way on B. They both have x squared plus 25 on the bottom instead of x squared minus 25. So we're down to either C or D. How do we know which one? Don't be too quick. Look at the horizontal asymptote, which is at 3. Positive 3, that is. Which one of those has a horizontal asymptote at positive 3? Well, horizontal asymptote is the highest power on the top, highest power on the bottom. So that would be 3x squared over x squared. Should be positive 3. Whereas this one would be negative. Right, there's a negative in front, 3x squared over x squared, which would be horizontal asymptote of negative 3. Remember, for horizontal asymptotes, we just take the highest power on the top, highest power on the bottom. So that would be negative 3. So it's not D, it's C, which has a horizontal asymptote at positive 3. So number 4 here, we're supposed to figure out the domain. How do we do domain? Denominators cannot be 0, so that means x squared minus 25 cannot equal 0. Factor that, x minus 5. X plus 5 cannot be 0, so x cannot be 5 or negative 5. B, Next one, what's the vertical? Same thing. 5 and negative 5. Those are the two places where the domain doesn't exist because there's vertical asymptotes. C, what's the horizontal asymptote? Well, let's go to a fresh screen. Okay, we're doing part C, trying to find the horizontal asymptote, or oblique, horizontal or oblique, as the case may be, which means diagonal. So, how do you do it? Highest power on the top, highest power on the bottom. X cubed over x squared. That reduces to just be x to the first power. Remember the rule, when the numerator is greater than the denominator, the numerator power greater than the denominator by only 1, then you get y equals mx plus b, first power, which means it's going to be diagonal, oblique, goes by either name. So the asymptote's going to be diagonal. How do we find the asymptote? We long divide the denominator into the numerator to find the y equals mx plus b equation. Denominator into numerator. Here we go. What up here times the front will match the front. What times x squared is x cubed? Well, x, and that x will multiply both. X times x squared will be x cubed, and x times minus 25 is minus 25x. And then we subtract. These cancel, and then we get minus 25, which is plus, right? That minus hits there. And plus 25x, bring down to minus 64. And that's as far as we can go. That's all just remainder because this power is lower than this power. So the answer is just y equals x. That's the diagonal, that's the equation of the diagonal asymptote, oblique asymptote. The last step, they want you to graph. Just use your graphing calculator for part D there on number 4. Okay, number 5 here, we're supposed to graph an exponential. What do we learn about exponentials? Well, in general, exponentials go up to the right, like that, and unless they've been flipped or something. So this one's clearly been flipped. Instead of going up to the right, this one's going down to the left. So it's been flipped sideways, vertically to go down, and then sideways to go left. It's been flipped both. So it has a negative in the front and a negative on x. That's what makes it flip down. The negative in the front makes it flip down. The negative on the x makes it flip sideways. So both negative on. So we're looking for something that has negative in the front and negative on x, because our graph has been flipped down and left. So can't be A because he doesn't have any negatives. Can't be B, he only has a negative on x. Can't be C, he only has a negative in the front. It could be D, he has both negatives. Can't be E, he has no negatives in the front or on x. Can't be F, no negatives in the front or on F. No G, no negatives in the front. No H, no negatives in the front. So that was easy. The answer is D, has a negative in the front, and on the x, flipped down and left. That is correct. You can plug in a point on a table if you want. It is correct. Okay, we want to solve this. So we got to, how do you handle it when x is in the power zone? How do you do it? You, number 1, make the bases the same. Step 2, set powers equal. So I can make both those 3. That 27 is 3 cubed. You can check it on your calculator if you're rusty on some of those times tables. 9 is 3 squared, I'm sure you remember. So now, it's a little scribbly here. Now we need to remember the power rules. So what happens? These powers multiply. So that's 3 to the 15x. And these powers multiply. 2x plus 2. So there we go. I made the bases the same. Now step 2, just set these powers equal. So I go, okay, 15x is, not 3, 2x plus 2. Because if the bases are the same, the powers must also be the same. Otherwise, these things wouldn't be equal. If those powers were different, 3 to one of them wouldn't equal 3 to the other. It's got to be equal powers. So subtract 2x. 13x is 2. And last step, divided by 13. 2/13. So our answer there. So number 7 here. We've got to make these bases the same. So e to the x squared is e to the 4x times. Now what do you do with something flipped down? That's a negative power, remember? And now, what do you do with two bases times? You add the powers. One base, right? Remember that old rule? So the two different e's, the two e's multiplied, you take their powers and add them. And so now I've done step 1. So bases the same. So when you have x in power, make the bases the same. Step 2, powers are now equal. This now must equal that. So x squared must equal 4x minus 3. So now I need to solve that. How do you solve that? When you have an x squared equation, you just get a 0, huh? Just jump these guys over. Get x squared, what's that? Minus 4x. Plus 3 is 0. Factor minus 1. Minus 3, because that way they'll multiply to be plus 3. Add to be minus 4. So x equals 1 or 3 are the two answers with a comma. Okay, number 8, we're looking at another exponential graph. So again, we remember that, oh no, I'm sorry, this is not exponential, this is a logarithm graph, right? We remember. Okay, remember that the general equation is log base b of x plus a, and that'll put the vertical asymptote over here at minus a, won't it? And the log will go like that. So the logs go up to the right. All of our graphs go up to the right unless they've been flipped somehow. Notice ours is going up to the left. So it's been flipped sideways, hasn't it? What makes it flip sideways? Negative on x. So we must have a negative on x. And what's our vertical? Vertical's at 0, so this part is 0. So we're looking for something like log of negative x, that the part added next to a in the parentheses is 0. So where do we have that? Do we have log of negative x? So it can't be a, because there's no negative on the x. Can't be b, there's no negative on the x. It could be c. Oh, but we have a 1 in there. It's a 1 added. It's negative x plus 1 in the parentheses. We can't have that. The vertical is at 0. So no way for that reason. No way on D. The negative is supposed to be on x. No way on E. There's no negative on the x. No way on F. No negative on the x. G looks good. Negative on x. H, he's got a negative on x, but he's also got a negative in the front, which would make the graph go down instead of up. So that's not right. So it is G, the only one that has a negative on x, and the asymptote, it's plus 0 in there for the vertical asymptote. All right, number 9, how do we solve a log? Let me write it here a little bigger. Log base 2 of 6x plus 8 is 3. Well, we've learned that logs and exponentials, powers, are the inverses, the opposites of each other. So whenever you want to get rid of one of them, you bring in the other. Like if you have a square root equals 7 or whatever, the way to get rid of that is you 2 power both sides, right? And you get x is 49. Or if you have x squared is, 9, the way to get rid of it is the root both sides, because that cancels that. So just like roots and squares are opposites and get rid of each other, so do logs and powers, as long as the bases match. So what's the base in this log? 2. So I do 2 on both sides, and that cancels it out, right? Logs are the opposites of powers. So what do we get then? It brings it down to be just 6x plus 8 is 2 to the 3rd, which is 8. Subtract 8 from both sides. 6x is 0. Divide by 6. X is 0. There we go. There's part 1 of practice exam 2.